right, guys? So we will be starting from Docker, and before starting the session, I want to know how many of you already aware of Docker and Kubernetes.
Just little about what is Docker, what is Kubernetes, that much only.
Okay. What about others, guys? Not me. Okay. Okay, Kalyan. Okay, guys. Yep. Give me a second. So I will be assuming that you guys don't know about Docker and Kubernetes. I will be starting from the scratch on the basic, and slowly we'll be moving forward to advanced topics. To learn everything, continuously attend classes, don't take any breaks. And if you're taking breaks, then you'll be having recordings. If you guys are having, any doubt and question, you can ask me. Do the practice day by day. If you're having any confusion, you can ask me next day at the topics. If you're thinking like I'm going fast, so you can tell me to slow down. Okay, so give me a second. I need to get my PPT and I'll share my screen, then we'll be starting in a minute. So yep, guys, this is my slide. So first of all, let's talk about a very basic thing, right? Forget about Docker. Let's say you guys are a developer. Okay, you are a developer or you are working in a company. You need to handle ops thing, operations. So guys, the first thing is that, like, let's say you want to you want to host one application on server, or assume that you are a developer and you need to write a application that is based on PHP, right? So what all things are required, guys? What all things are required to host your application on server? Hmm. Can anybody tell me about it? Let's make the session interactive, guys. If so, like, if you guys are having any confusion queries, so you can ask me anytime, right? If you don't know, we are learning here. I'm not taking any interview and all. You can ask me the things, right? So so that you will be having very clarity about each and every topic, right? So yep, guys. Can anybody tell me what all things are required to host one application on server, right?
The application might need some database.
Okay. And what else?
Servers need.
In a very minimal sense, we need hardware, some hardware for hosting,
Right. Mm-hmm.
and basically the operating system and the software.
Correct, guys. So even assume that you are a developer. To develop one application, let's you want to develop PHP based application. What all you need? First of all, I need to have one laptop hardware. On top of hardware, I'll be having one operating system. I will be installing my compiler, and I will be installing my web server, so that I can compile or I can see output of my web application on the browser, right? Once this is done, once development is done, again I need to have I will be requiring the same thing to host my application on server, right? I need to have one server, and that server will be having operating system, and then we'll be having compiler binary, and then be installing no, we'll be installing Apache web server there, and our binary library and our code together will be writing there, so that we can make it accessible our website or web application globally. This is the thing. Now think about in this way, like, in corporate, in enterprise level or project, how people are working. See in this slide how people are working. Developers will be doing their job, means they will be developing the code. Once code is developed, they will be they will be testing it in their own personal computer laptop. They will be testing. Once code is done, they will be pushing that code to centralized code repository, Git or SVN, anything. And then once it is done, then once they push the code to SVN, they will be dropping mail to ops team saying that, just go guys, just this code is done, just deploy it. Legacy thing I'm talking about now, I'm not talking any containerization. What ops team will be doing? Ops team will be pulling the code and they will be deploying that code to respective environment. It could be your production, it could be UAT, it could be QA, anything, any environment. Let's say this guy, he pulled the code and he deployed to his respective environment. He started seeing bugs there. There was some error, some issue was there. So what this ops guy will be doing? Simply, can anybody suggest me?
code will again we will request to check with developer.
Correct. So we need to drop to mail, or we need to talk, we need to call to developer, Skype call, or meeting will be arranging, saying that developer, this guy, this bro, your code is not working, this is faulty, and this is something issue and error. We started communication with developer guy. What will happen now? Here the mess starts. Now the thing is that a developer will be saying to this ops guy, saying that, bro, that code was working on my computer, right? Why it is not working in your environment? They will be started troubleshooting it. They will be consuming a lot of time. Finally, even like 1 or 2 hours, they are getting to know, or even some time, few minutes, even they are getting to know that what was the issue. What issue they faced is, the issue in their environment is that in their environment they are using PHP 6.0. Okay, developer used latest version of PHP to develop that code. Now what might be the issue is, he used latest version of PHP, here older version of PHP is running. There might be few function deprecated in newer version of PHP, and older version of PHP, those new feature or new functionality that developer used in his code, that might not be supported. That is the reason this ops guy was seeing some issue and some errors there. Now what these guys will be doing, will ops guy will update his PHP version 7.0, or this this developer will have to downgrade his PHP version and write code again? Once we are going back to write code again, it is just like taking few days or few weeks. So which one will be the best practice here, to upgrade existing code in environment, or writing code with same version that we are using in our environment? Yeah guys, can you please tell me, suggest me?
First, developer has to inform when the latest code is moving to QA, UAT or live. After that only we have to check that which version they are using.
Clearly we've seen that one issue was there, like PHP 6.0 is in our older version of PHP is in our environment, and this developer guy, he used latest version of PHP. So what this ops guy will be doing, will he update to make it code executable or run here in this environment, or he will be telling he will be telling developer to downgrade your code and rewrite your application again? Which is the best practice?
We will do a version update.
He'll do
We'll
version
move
update.
Yeah.
Okay. What about others?
And we will check that version it is having any issues or not. First operation will check this version is any issue with that server.
Okay.
After that only we will update.
Okay. What about others, guys? Suggest me anything. You should tell me, right? Yeah, guys.
We need to update the version in environment.
Okay. Okay. So the thing is that, guys, never to update a version in your environment. You will be having admin rights. Don't do that. Never to do this kind of thing. Because there might be some other application already running on your server. Whenever we are talking about like in our environment, prod, QA, UAT, anything, we might be having so many application using the same version. If you are updating this version in the environment, those application will be affected on only this new application will be started up again. This might lead big acceleration. If it is a production, there's chances that they can terminate you. Okay, never to do version update, because whenever we are planning to version update in our environments, we need to take so many approvals. Then only, guys, we can do version update. Simply here ops guy will be telling to developer, bro, downgrade your PHP version in your personal computer or laptop, and then write code accordingly to that. Right, this is the best practice. Right. So now Docker, how Docker is solving this issue here, right? So now let's see the Docker. What Docker exactly is doing is, again, to host a Docker or containerized based application in our server, things are required is one server. On top of that server, we'll be installing operating system. It could be your Ubuntu or CentOS or RHEL, any Linux flavored operating system we use. On top of your operating system, we will be installing Docker engine. Okay, how Docker is solving this basic requirement to host to containerize the application, Dockerize the application, we can say. Now here, how Docker is solving the thing, how this thing we are seeing that version mismatch is happening and this and that is happening at this time. Here, we spent a lot of time to develop new code and to test it again, to deploy it again. Here, what Docker is doing, developer will be writing the code, and you will be, or in some organization, developer will be containerizing application, or ops team in some organization, if it is a big project, so company will be having separate people who will be containerizing the application. What container will be containing in it, that we need to understand. Container will be containing operating system in it, okay, and we will be having our own compiler, our web server we will be having there, we will be having our own binary, our library on our project or our application, all those things wrapped together in one container, and we will be deploying that container in our containerized environment in our server where Docker engine is already running. Here, let's say multiple applications are running, so they will not be conflicting each other. Your application, whatever version you are using here, PHP, no need to think whatever version of Apache it is, whatever configuration you are writing, those things will be wrapped in a container, and these will be running as a separate process. And they, let's say, let me start on this page here. This is my server. It might be having a hybrid. I'm going to do 168.1.20 for an example, and here I will be having operating system, and then I will be having here Docker engine installed here. Now I'm creating one container here, right? Here I will be having one application, here I will be having another application, here I might be having another application. Okay, app1. In this application one, I will be having my code all together running in it. I might be running my code on, let's say I'm saying HTTPD. Okay, so guys, a simple question that I want to ask you: how many Apache we can install in single server? How many Apache we can install in single server? Any clue on that, guys?
Only one server, right?
Yeah, we are having one server. Like here we can see that for an example, this is my server. Forget about Docker. Here I want to install Apache. How many Apache I can have on my server? Any clue on that, guys?
Only one server.
Yeah. Okay. We can have one server. We can install one server. If you guys are using here apt or yum, okay, apt install command here, so you can install Apache 2. So here, if I'm saying that I want to install Apache, if you are installing Apache by using apt command, so you can have only one server. Next time you will try to do the same installation again, it will be telling you latest version of Apache is already available. But if you want to execute multiple Apache server in same system, same server, we can do that. What we need to do at that time, we need to make few configuration changes. Port number we need to change, we need to few things we need to change, and we can do that. But that is not a best practice. We should have only one server on our one Apache and one server. That is a good idea. Here in Docker containerized environment, we can create a multiple Apache container here. Multiple Apache container we can create. HTTPD. Multiple applications can have same compiler or same servers here, app2. Now, how it come possible? We can do that. This is my app3. Let's say in same server we are installing a multiple Apache. So what we need to do, we need to make configuration changes. Here we no need to do anything. You know, whenever we are talking about containerization, so each container and its resource will be isolated. They will not be they cannot communicate, they cannot create problem, they cannot conflict to each other processes. Same Apache process might be running in same container. The magical thing about that is like, you know, you can access these Apache processes, or you can see these HTTPD process. You know, you can search them on your host machine. These can be accessible on host machine, but still they will not be able to communicate them. What is the feature that is making to work like this, and how we are isolating it? We will be talking, and we will be, you know, discussing about those components. They are making these process available to run independently without conflicting each other. That I will be talking in my further slides, further sessions. I'll be talking about those things. And this is how, guys, if your containerized application is ready, what you need to do, you need to deploy this container on your Docker Engine server, and just Docker run command, and you can make your application up and running. Even if your multiple codes is already running, you no need to think about versioning thing, you no need to update anything, because your compiler, your web server, everything is wrapped together in a container, and that will not be conflicting to other programs or other containers. Getting it, guys? Till here, everything is clear or not? Yes. Can you please give me a quick confirmation on chat or mic, based on resources? Okay, something, yeah.
Yeah, till here it's clear.
Okay, so let's proceed for another slide. That is, you know, Docker architecture. What a Docker architecture exactly is? You know, whenever we are installing Docker in our system, it's two major components will be installed on your system. First one is a Docker server and Docker client. We can say Docker daemon and Docker client. Both will be having their own responsibility, their own roles. Docker client, we will not be you know, executing a Docker client separately. It will be installed in same machine, same time. And the thing is that the use of Docker client is only this, like, you know, it will be receiving user command, Docker run, Docker exec, you know, Docker ps. These command will be received by this Docker client, and it will be taking action. To take action, it will be sending that to Docker server. Let's say simply I want to create a container. To create a container, I need to execute Docker run command. That Docker run command will be sent to my Docker daemon or Docker server here. What will happen at the time here is Docker server will be looking it out that required image is available locally on the system or not. Always remember that container can be created by using Docker images. Okay, once so basically container will be created by using your Docker images. And once Docker daemon is getting to know required image is available on my server, the same server, so it will be creating the container, okay, by using that image. If required image is not available locally, then what will happen? Docker server, Docker daemon will be going to its default registry called hub.docker.com, and it will be searching whether that required image is available on hub.docker.com or not. If it is required, then it will be pulling that image locally on the machine, and it will be creating containers. Okay, so it is very simple Docker architecture. This is very simple Docker architecture, and a few things. Okay, here we are having some comparison about, you know, virtualization and containerization. And I need to tell you one more thing that I told you here, how these containers are getting created and what all core component that is making, allowing to create containers by using them. Let me get my another PPT. Give me a second, guys. Where it is? Somewhere I kept it. This VCC drive, T drive. So yeah, guys, this is it. This is my another PPT. Here we will be seeing, just now we see what is Docker. Okay, Docker architecture we seen, and now we will be seeing virtualization versus containerization. Okay, what virtualization is exactly and what is containerization. Okay, so guys, let me scroll it down somewhere where my virtualization is available. Virtualization slide. Yeah, this is my virtualization slide. So virtualization, what exactly virtualization is? Okay, can anybody tell me about a few small definition kind of thing what virtualization exactly is? Yeah, guys, what is virtualization? Nobody wants to say?
Okay. We are basically sharing the resources of a server across multiple applications or multiple servers, right?
Yeah, so let me talk about this one. Virtualization, whenever I am talking about virtualization, so I will be creating virtual machines. What all things used by those virtualization virtual machines basically? So whenever I want to create a virtual machine, so I need to define a few resources to them. What those resources could be? Those resources will be your RAM, right? I'm virtualizing my hardware. So whenever I'm talking about virtualization, means we are talking about hardware level virtualization. Here in this virtualization, I need to define my hardware resources to virtual machines. I will be saying that no, this much GB of RAM I'm allocating to this virtual machine, this much of CPU I'm allocating to my virtual machine, this much of hard drive space I'm allocating to this virtual machine, right? So basically virtualization is, this is a term that we will be using for virtualizing your hardware devices. Here, let's say I want to create 3 virtual machines. Okay, I will be naming them, app1, app2, and app3. 3 applications we can host in them, and how I will be creating virtual machine. This is the important thing. Basically, we are having 2 type of virtualization, type 1 and type 2. Type 1 virtualization, where you will be installing your hypervisor directly on your hardware. Okay. Type 2 virtualization, we will be having, first of all, a host operating system on our hardware device, and on top of host operating system, we will be installing our hypervisor. Hypervisor will be the software that will be allowing you to create virtual machine. It could be your Oracle VirtualBox or VMware player. Getting it? So once my hypervisor installed, I can create a virtual machine as per my requirement. And how many virtual machine I can create, it totally depends on my computer's hardware, right? It depends basically, because I need to assign, few amount of hardware resources to my VM. As soon as your VM is, getting powered on, those resources will be allocated to that particular virtual machine, and dedicatedly they will be available for those resources dedicatedly will be allocated to your virtual machine, and that cannot be utilized even for your host machine. Okay, your host machine can't do anything with that. Once your machine is going down, and it will be releasing those resources, and those resources will be again available for your host machine. Now here, let's say for an example, here I'm having one of my virtual machine, and this is having its own operating system, separate operating system, and we'll be having our separate binary library, and our application will be hosted on top of that particular virtual machine. Now the thing is that I'm having 3 virtual machines. I allocated 1 GB RAM to this, 1 GB to this. Each of these VMs are having 1 GB of RAM. Think in this way, like this app one is using a 900 MB or 950 MB of the RAM. In simple word, it is consuming more resources. It needs more resources. 100% or 99% resources is utilized by this app1 virtual machine, and this app2 is using only 100 MB of RAM. Rest of 900 MB is just unnecessarily located to this one. This app3 is using the same, is doing the same thing, like it is using 200 MB of the RAM, and unnecessarily we are having 8 GB RAM allocated to this one. Here my app1 need more RAM. Okay, at the time, can this app1 share or ask app2 or app3 to give me your RAM to me? Right? Is it possible? They can allow them, they can, app2 or app3 can allow app1 to share its memory, or can it ask to app2 and app3, like, can you share your resources to me? Is it possible, guys?
No.
No, right? Even if you
Strictly
want to
no.
do the,
Strictly no.
yeah, even if you want to do that, then you need to take down these VMs, and then you need to increase decreasing resources. Then only you can do this thing in virtualization. Now we seen that unnecessarily resources are allocated to your VMs, right? Now Dockers in containerization, how containerization is working. Whenever we are talking about containerization, so it is operating system level virtualization. What it does mean by operating system level virtualization? Resources, we just seen that our virtual machine, we are allocating resources to them, and those resources are getting blocked permanently, whether they are in use or not, it doesn't matter. In containerization, as many resources is required, those resources will be accessed by your operating your container. Sorry, only required resource will be accessed or utilized by your containers. Okay, let's say I need only 1 GB of the RAM, so only that much RAM will be accessed from my host machine. As soon as my memory utilization is going down, I'm just going down to 500 MB of the RAM, then another 500 will be already released to host machine, so that another container can see those resources. Okay, they can utilize those resources. In containerization, basically we will be using operating system level virtualization, where operating system will be helping our container to run independently without any trouble. Now the thing is that how it is coming possible. We are installing Docker. In Docker we are having few components. We'll be talking about them just now after this. This is one more example here. In case of virtual machine, let's say in my host machine I'm having 16 GB of RAM, and I'm allocating 6 GB to one VM, 4 GB to another VM, 6 GB to another one more, third VM. Here first VM1 is utilizing 4 GB of RAM, and here we can see that 2 GB is freely available. Okay, 4 GB VM2, we allocated it, 3 GB is utilized by this second VM, and 1 GB is free here. Same thing in virtual machine 3, 2 GB is utilized here by your third VM, and 4 GB is free available. Means totally a 9 GB RAM, we are seeing that it is required to execute your programs, and unnecessarily 7 GB is allocated to them. There is no use of them. Even host machine cannot access that much of RAM. In case of Docker container, as much resources is required, only that much resources will be accessed from host machine directly. Even as soon as those resources are not required to use, or it is decreasing requirement resource, so those resources will be again freely available for your host machine, so that another container or another application use them freely. Now here, let's go down in the slide. Virtualization versus containerization. Virtualization in size. Okay, virtualization is very heavy in size. First of all, we need to allocate resources to RAM and hard drive space to it. Basically, if you want to install Ubuntu in your virtual machine, you need to allocate at least 5 GB hard drive space. You need to allocate 5 GB hard drive space to your virtual machine. Okay, and then RAM and then CPU, right? If you're talking about Docker containers are lightweight. Okay, hardly you need to, if you want to get Ubuntu operating system in containerization, so hardly it will be in size 150 MB of the RAM. Okay, starting up, let's say we are starting our virtual machine, so it will be performing like complete startup process, like it will be performing post power on self test, and then mbr, then grub, and then init process or systemd, and then targets, like everything. It will be starting things from the beginning, and it will be taking a lot of time. At least 1 minute it will take, 1 to 2 minutes it will take to power up properly your VM, right? Here in containerization, as soon as you're pressing enter key, your container will be started with its own operating system. Integration, to if you want to integrate it with some third-party tool, or you want to orchestrate it, then it is very tough task. In case of virtual machine, in Docker containers, we can do easily. Now, let me talk about few components of Docker container. They are helping us to create container. This is the component, Docker internals. So
Yeah,
in Docker
Anish,
internal,
yeah, one moment. Sorry for disturbing you. And in the real time for the VMs, we often used to reboot the servers, right? Reboot either Windows or the Linux, whatever it is. In that scenarios, do we need to reboot only the container based, or we need to reboot the host machines also as well?
no,
If
containers
there
are
is
not
any
required.
down,
Containers
if
are not required to reboot.
okay, if there is any application unresponsive, or if it is a CPU utilization, is something went wrong, then what is the action plan we had to do it in terms of the VMs and content based applications?
Okay, good question. So for this, so think about it in this way, like your application is running fine here. Let me open this one. Yep, this is your container app1. It is running fine. There is no problem. And meanwhile, you started facing some trouble, right? You started facing trouble, like this application is not working. It is killing again and again with error OOM, out of memory, or something like that. So what you guys will be doing? So this is, guys, only Docker server. This is my Docker server. Here only Docker is installed on top of my operating system. So basically, what we want to do is we need to achieve highly availability. We cannot achieve highly availability by using single server. To achieve highly availability, what all things are required? We need to have multiple server. Getting it, guys? We need to have multiple server where we will be installing Docker, and we need to create multiple containers to achieve highly availability. Let's say one container is down. Let's say, for an example, this container is down, then another container with having similar application that should started serving the traffic, right? What we will doing to achieve highly availability is we will be creating multiple server in Kubernetes. In Docker, if you want to achieve highly availability, guys, we need to use Kubernetes or Docker Swarm, right? In Docker Swarm and Kubernetes, what will happen? We will be focusing more on Kubernetes. Let's say this is give me a second. This is one of my Kubernetes node. Okay, Docker container alone can't do anything. If it is a Docker, only you are thinking, or you are depend on only Docker engine server or Docker server. If this application is down, then you can't do anything. You need to test. You need to continuously monitor to log in that my application is working or not. Even if you are installing any monitoring tool on it, you will be getting to know this application is down. But here there is no solution that will be automatically restarting your container again. only one option that you will be having, you need to write a big shell script. That shell script will be continuously pinging to this container if this container is not available or it is getting it got down. So at the time your shell script program will be killing it and restarting it. This is a thing that you can do. That to manage these containers in proper way, what we need to do is we need to go with Kubernetes or Docker Swarm. What will happen in Docker Swarm and Kubernetes, we will be having multiple servers available with us, like this. If this application container is down, so what will happen is wherever your container is running inside your in your cluster, so second same applications container will be started serving the traffic like this. This will be serving the traffic even if this node itself it is going down. So your traffic will be served from second node, from this node, and whatever application is running here, that application will be started serving the traffic. If your application container is down or it is not working properly and it is facing some issues, so what Kubernetes will be doing, Kubernetes will be killing this container and will be recreating this container to make it up and running. You will be having few probes. You can check it out whether my container is up or not. You can check it out even my application is running inside that container or not. You can allocate a few amount of RAM and CPU to your containers in Kubernetes. Docker engine will be used to create or to containerize your application alone. We will be learning, guys, everything from the scratch, how to secure your application, right? What are tips or what all things we need to follow to make it secure our application, right? In Docker as well, from the Docker to Kubernetes. Okay, each and everything we will be moving forward slowly to run them. So I hope I gave your questions answer. Surya, I guess Surya asked me this question,
Yes, exactly.
right?
Yeah, Anish, and these future
Mhm.
is auto reboot or self fill feature is available only in the Docker Swarm, right? It's not in the Docker.
So, okay, I'll tell you. So when it comes to automatic reboot and all those kind of thing, containers will not be rebooting. You no need to restart or reboot your container. What we will be doing here is we will be having in Kubernetes few probes, health check. We will be performing some health check to check our containers health. Not only containers health, we can check our containers, whatever application running in that container, we can check that application's health as well. If container is not working properly, so Kubernetes will be recreating the container and will be performing check over there. If your application is not working inside the container that you containerize, so again in this situation container will be recreated on your system. Yep. Here if any host is down, all containers will go off, right? Okay, okay, Naresh. So the thing is that if this host itself it is going down, one of this host itself it is getting down, so what will happen here at the time? let me tell you let me tell you few things more again here. This container itself is down now. What will happen now? What will happen is your container, whatever runnings in this machine, they will be down also, because host machine itself is not there. Then why container will be there? First thing. Second thing, in Kubernetes, how Kubernetes is working, that is very important thing. In Kubernetes, we will be creating, a group of server. We'll be having our own cluster where we can have, for an example, I will be having one master node. I will be having here one master and two worker node. Okay, we will be having one master node and two worker nodes. Okay, three nodes total we will be having, and our deployments will be getting created on node number 2, guys. On second node, our deployment will be getting created. Now here, assume that this is my Kubernetes worker node. So whenever I will be deploying or creating containers in Kubernetes, I will be using one object called deployment itself. Deployment. We are having basically 3: replication controller, replica set, and deployment is advanced one. So always we will be going with deployment, and we will be defining that how many replicas is required of your application in cluster. Let's say I'm saying in Kubernetes, I need 3 replicas should be available on my server, on my cluster. So what will happen here is 3 replica of your application will be created on the system. One replica will be created on node number 1, okay, and second replica will be created on node number 3 here. If this, I'm saying 3 replicas, so round robin process, a scheduler follows. First replica will be created on node 1, second will be created on node number 2, and third will be created again on the same node here. So what will happen is this container is down, so it will be started serving, second container will be started serving the traffic. If suppose this node itself is going down, then here what will happen is in Kubernetes, another node where my application's replica is available, that replica will be started serving the traffic. Here one more catch is that as I defined 3 replicas should be up and running on my cluster. If somehow one of my colleague, by mistakenly deleted my containers replica, and this replica is deleted now, what will happen here? So Kubernetes will be making sure 3 replica means 3 replica immediately. As soon as this replica is getting deleted, immediately Kubernetes will be created. It will be creating third replica here on the same place. It will be creating one more replica for you guys. This is how it works. Getting it? We will be having multiple server where we will be having our applications replica, and it will be serving the traffic even if one node is down itself. And one more thing, once this node is getting down, once this node itself is getting down where few of deployment was running, so what will happen once this node is getting down? Once node is getting down, within another 5 minutes, all the pods are running in your node that is currently down. All those pods will be, all those containers will be evicted, and those container will be moved to whatever nodes is up and running immediately. Within 5 minutes, they will be moved. We will be learning things from scratch, how it is happening, which controller is working behind the scenes to create container, who is testing, who is making sure this container is running or not. Everything, guys, from basic to advanced level, we'll be learning. I was talking about here about Docker container internals. Once it is completed, then I will be moving forward to Kubernetes to give a simple structured overview of Kubernetes, how things are working, how we are making them accessible. Let me complete this thing. It will not take more time. Only it will taking 5 minutes. That to tell you what all Docker internal component that is helping us to create containers. Yeah, guys. Any question regarding that one? Naresh and
Yeah,
Surya.
Anish, and replication will have the different Docker ID or image ID, or it will have the same ID.
Okay. So slowly we will be learning that Docker ID is nothing but, in Kubernetes we are having one more feature called pod. Pod is nothing but container of containers. We can contain, or pod can contain multiple containers inside it. As soon as you are creating pod on your system, so Kubernetes will be naming them uniquely. They will be, if you are writing something, deployment name MIDER. So Kubernetes, once it started its replica, its replication on the system, so it will be assigning some unique name to it. Okay.
Okay, that is a static, right? That's not. It's a static or it's a dynamic.
Dynamic. Whenever you are creating a container, and even containers also, whenever we are creating container or pod in Kubernetes, if that container pod is deleted, whenever Kubernetes will be recreating it, so it will be getting a unique name. Dynamically, it will be changed. It is not fixed. In Docker also, if you are creating container, once your container got deleted, second time whenever your container is getting restarted or recreated, it will be having one new ID to it.
Okay.
New ID will be allocated to it. We will be learning everything. Don't bother for that. How to enable communication between pod to pod, container to container. Everything is here. So let's talk about Docker internals. What these Docker internals are. In Docker internals, we are having few component like to store in kernel level. So we are to store our data in our container. So here we will be seeing device mapper, BTRFS and AUFS. Basically AUFS is replaced by overlay 2 to store your data. Docker container will be using overlay 2 drivers to store your data in namespaces. Namespace is another very important component. What this exactly is, namespaces is nothing but it will be separating the process. Whenever we are creating a container, let's say I want to create 2-3 nginx container, 2-3 Apache containers, what will happen is namespace will be wrapping that process. It will be isolating that process, so that that process will be thinking that resources are dedicatedly available for only for that process. It will not be conflicting with other processes. Networking to enable container to container networking. Here we are having one feature. A few drivers will be having available called bridge and host and all, and they will be helping us to enable networking in our Docker server, and we can communicate to our Docker container. C group drivers. C group is a very important component. As I told you, only required resources will be accessed from your host machine. So C group is a component that will be helping our containers to access your required resources like RAM and CPU, or your whatever required resources we are having here, RAM and CPU and all those things will be accessed by using this C group. To make secure your container, we will be having here a seccomp acid linux component that will be helping us to secure our container. As per our firewall rule, they will be allowing traffic to reach this container. This was few Docker internals, and let me talk something about Kubernetes, how Kubernetes is working, and complete diagram I'll draw here. Okay, one master node and two worker nodes we will be learning about. Black color is good. This will be my master node. This will be my worker node. Okay. Basically, I will be having, one master and two worker. Or two worker, that's fine. Master node. This will be my worker 1, and this will be my worker 2.
Yeah, master node means host name, host, right?
No, master node. Whenever I'm saying node means like it is a server. Master server, worker server, worker server. We'll be having separate machines, separate virtual machines. Here we'll be having our own operating system. We can say Ubuntu. Okay. Everywhere we will be having same thing. Here we will be having our own IP address. Each node will be having its own IP address. 192.168.1.20 for an example. 21 is having separate IP address. 22 like this. So each node will be having few components installed here. Let me write them. First of all, each will be having Docker installed in it. Then kubectl, kubeadm, and kubelat. These things will be available each of your nodes. Each node will be containing this information, these tools in it. Let me okay, that's fine. These things will be running there. Docker, we know that what Docker is. CTL is nothing but a binary file that will be allowing to interact with your Kubernetes cluster. Basically, kubectl, if it is not here on worker node, that is fine. It's not required here. But these components, these two things, kubeadm and kubelite, should be here. Kubelite, we'll be learning about kubelite also, but I'm just giving you one simple overview what exactly it is, Kubernetes, how things is working in Kubernetes, guys. This thing I'll be telling you here. So let's say master node will not be having your application container in it, because it is a master node. It will be managing its worker node. It is responsible to create deployments in your worker node. Why master node is not getting created your deployment application here? It is not deploying application containers in it because it is a manager node. It will be managing its worker. Application is if we are installing or creating application container in master node. So what will happen at that time, guys, is master application also need resources, RAM and CPU. Master node will be having few components running in it to manage your worker node. That is also required resources. If master node's main core component, they started facing trouble for resources, so how they will be able to manage your worker node, your deployment, right? It will not be working properly. That is the reason master node is not having any deployment by default. It is not allowed to create your application in application container or application deployments in the master node. Whenever you are creating a single pod or single application or replicas, so those pods and replicas will be created only on worker nodes. Okay, here your containerized application will be created here. Now I want to deploy one application on my cluster called app1. For an example, this is my app1 application I want to deploy in Kubernetes cluster. The good way to apply or create your to deploy your application in Kubernetes cluster is create its replica. Create its replica, 3 replica, 4 replica. It totally depends on us. In case if one container or one pod is getting failed, so second available pod or second available container, don't be confused in this term pod and container. In Docker server, Docker engine, we will be creating containers. Let me tell you here, in Docker we will be creating containers, container directly. In Kubernetes, we are having one term called pod. Pod will be containing containers in it. Okay, container will directly not be created in your Kubernetes. Container, whenever you want to create container, you need to keep that container in a pod, then only it will be getting created like this. Pod is nothing but container of containers. Think it is here, this one. So here I was talking about a replica, how replicas are working here. So let's say this container, this pod is down, so another available pod will be started serving the traffic. Even now, if this node is going down, if this node itself it is going down, it is not available, so this available node will be started serving traffic with its container. Okay, this is how it will work. For an example, somehow this node is back again. We can assume that this node is back again, and this application pod, okay, itself, it is deleted, where you defined you should have 4 number of replica. Okay, f1 should have replicas equals to 4. So Kubernetes will be making sure your app1 should have 4 replica running in cluster. If any one of the pod got deleted, so new pod immediately will be created in place of that. Immediately it will be creating that one. Getting it, guys? So this is how it works. So here in containerization, how we are making our application out accessible outside of the machine, we are doing port mapping there. Just writing -p and host port to container port. This is how simply we are doing that in our Docker. Same thing if you want to do in Kubernetes, we need to create services. We need to create services. We need to create services here. This will be my service. Let me choose black color. Service to make it accessible your application. Okay. You need to write YAML files. Don't bother for this, guys. I'll be telling you how to write YAML file and all. We will be creating services, and this service will be allowing to access your your application outside. To make it accessible, your application outside of the cluster, you need to create service. Basically, we are having three types of service. First one is cluster IP service, and second service that is node port service, node PORT, node port service, and third one is load balancer service. What cluster IP service is basically, let me draw another diagram here that will be making more clarity to you guys here. I'm just creating one pod. This is one of my pod. This is one of my pod. In this pod, I will be having one container or two container or three container. It totally depends actually as per my requirement. Let's say in my pod, I'm having two container. If they want to communicate, how communication will be happening here? It is quite easy, guys. They can access, this is my app container and this is my DB container. Okay, my database is running here, my DB container. If my application wants to access DB container, so how it will access? Just localhost colon port number 3306 is the port that will be used by MySQL. So my application container will be pinging or sending, it will be sending request to second container's port number to enable communication, to communicate with it. It is quite easy, no need to create anything, just use this localhost and this container's port number to interact with your database. So this is how it can access very easily. But assume that the same application is deployed in form of different part. This is my app1 container, and here my database is running in separate pod it is running here. Okay, DB. This is my DB pod DB here. Now this pod wants to communicate to this pod, then how this communication will be happening? This want to communicate to this pod. This pod is available in separate or different node itself, then how it will be happening? This is called pod to pod communication. To enable pod to pod communication within cluster, then cluster IP service is a choice. Cluster IP service will be making accessible your one pod to another pod. Okay, app1 wants to communicate to DB pod. This is how communication will be happening through cluster IP service. It will work. Getting it? So how this service will be getting to know? It will have to reach, or this service dedicatedly is created to make it accessible at this DB pod. So basically in Kubernetes, we will be having labels. Okay, labels assigned to this container. Labels. For an example, app colon DB. This label I assign to this database pod. So what this service will be doing, this service will be having selector. The selector will be selecting pods based on their label. Okay, whatever request is reaching to this service, it will be allowing, it will be sending or it will be forwarding a request to that particular container where its label is matched. Getting, guys? If you want to make it accessible, your service, your application outside of the cluster, how it will work? So request will be reaching from outside to this service. Okay, this service will be having its own port number. We are talking about node port. So node and the port, node's IP with port combination, node IP and port number combination will be here. Basically, node port service is having its own port range from 30,000 to 32,767. Overall, 2,767 ports is available that can be utilized by your node port service. You can fix node port port number also for specifically services. You can do that. So if your request is reaching from outside to this port, so this service will be routing request from here to your application directly. Again, the based it will be selecting ports based on the labels. Getting it? We'll have to discuss about master nodes component. Those are Kube API server, kubelet, and your scheduler, controller manager, etcd, and there's so many components, guys, that we will be discussing in our further lectures. What these components are, how to deal with them, what their roles is, right? This is just an overview I gave you here, that how your application is getting deployed in Kubernetes cluster and how you can make it accessible outside. If one container wants to talk to another container in the same pod, this is the way that will be followed. And one container, if one pod itself wants to talk or communicate to another pod, then cluster IP is the service. Load balancer can be created on cloud. Okay. So yep, guys, that's it from my side about Docker and Kubernetes. Docker's complete theory and Kubernetes just overview. We didn't see an architectural overview, but we seen that how application we are creating, how containerized application is getting created in your cluster, how their communication is getting enabled. There are lots of things that we need to discuss about Kubernetes that I cannot complete in one session. So I hope, guys, you enjoyed the session. If you guys are having any queries regarding today's session, you can ask me now. Yeah, guys. We will be learning everything to make secure our application, to deploy them on Kubernetes cluster, how to containerize application, how to create a container container images, and then how to run our application with specific user. Those things we will be learning, guys. For today, I'm done.
Kubernetes admin part also we are going to cover in this session.
Yeah, Kubernetes will be there, right? Let me tell you course content first of all. Let me tell you.
Admin part I'm talking about.
Specific topics. Admin part means what?
There will be like a Kubernetes admins, right?
So the thing is that, see, I'll tell you. In Kubernetes, we will be learning everything. Let me tell you. Let me. How to create deployments, how to administrate it, how to create cluster from the scratch, right? Those things will be there. Yep, guys, see this course content. We'll be starting from Docker engine. See, you might be having this course content. We'll be starting from Docker engine basics and few things about Docker Swarm. So Swarm we'll be seeing Docker Swarm as well, and we will be focusing more on Kubernetes. Okay. In Kubernetes, this cover all the topics. Some message came from Suman. CKA certification. Yeah, guys, you can go for CKA certification, but my suggestion is that practice well. Whatever I'm teaching you, practice well and just go through a few dumps. You can achieve your Kubernetes certification, CKA certification as well. And we will be learning that all those admin and deployment kind of thing here. Replication controller, replica set, one node is down, then how to update existing, how to update your existing version to newer version, how to take backup of your cluster. Those things will be here, guys. Replication controller, replica set, daemon set, stateful set, volumes, services and secrets, config map, ingress controller, HPA, scheduling probes, affinity, anti-affinity. Total for dedicated session we'll be having for scheduling thing, job and cron job, things about Calico to enable network rules, dashboard deployment, and Helm chart also we will be having here. Helm chart also will be seen. Yep, guys.
Yes, what about the monitoring tools like as in Splunk or Prometheus or Graphene or anything like that?
We will Splunk and Prometheus and Grafana needs to. I can give you overview only how
Yes,
it
yes,
works, how to
overview
deploy.
only, just overview only.
Because Splunk needs to be a lot of things to be covered there. Alone Splunk and Prometheus also Grafana and ELK, EFK. These are the topics that I can give you small overview how they works, right?
Yeah, the Splunk having the few of the limitations that I'm not sure about that how it will work in the container-based applications, but but most of the but most of the content-based applications are going for the Prometheus and Graphene, right? So we want this some of the overview of how it's working and what is the functionalities, these all things as well.
Okay, theoretical part I will tell you about it. To implement Splunk and all, it is not possible for me to implement complete Splunk things in here. I'll tell you
Okay, in the
theoretical thing
real-time
how.
scenarios for the
uh,
for the Kubernetes for the using the Splunk or or Prometheus or Graphene, which one is preferable to log in to monitor the
from
host and as well
yes.
as container-based application and pod also?
Okay, I'll tell you. So what happens is, let's say Prometheus Grafana. Prometheus Grafana will be, it is a monitoring tool. Okay, to see how much your container is containerizing, how much resources is accessed by your containers and all. That can be done through Prometheus and Grafana. Now, to logging, when it comes to logging tool, we are having here ELK. Okay, ELK's overview is already included, I think, in our content. How it was Elasticsearch.
ELK means I think it's a different topic, right? It's coming about the AWS, right? I'm not sure about it.
No. Elasticsearch, Logstash, and Kibana. Combination of this, full form is Elasticsearch, Logstash, and Kibana. So Elasticsearch, like Splunk, what Splunk is doing? Okay, let me draw something here. What Splunk is doing, guys, let me tell you. Splunk. It is storing logs in it, correct? It is storing logs in it, and it is visualizing them. You can search them. Visualizing it, right? It is visualizing it. But here in ELK, what is happening is these three components, these three components, they will work together. Elasticsearch will be storing logs. Store logs in it, first of all. Okay. And Kibana will be visualizing them. Kibana will be visualizing the log. Okay. In good manner, like you'll be having very nice dashboard. You can query it. You can search logs there in Kibana. Logstash. Logstash. What this Logstash will be doing here is Logstash will be receiving log. Okay, it is log receiver basically. It will be receiving the log and it will be storing logs in Elasticsearch. Logstash will be receiving log and it will be storing the Logstash. Who will be sending logs to Logstash? This is one thing. Okay, we are having beats. We are having beats like FileBeat. Basically, we'll be using FileBeat. FileBeat will be sending logs to Logstash. where these beats can be installed. Listen it very carefully. If you are thinking that I need to get log specific from container, what you can do is you can install this beat inside the container. Only this continuous log will be started sending to logstash by using file beat. Getting it? And logstash will be receiving the log, and it will be storing them through Elasticsearch, and Kibana will be visualizing them. Splunk also. Splunk is a complete tool where it is having its own on visualizing tool that we no need to install separately, and it will be storing logs in it. So we are having HTTP Splunk forwarders. Okay, we will be installing Splunk forwarder, whether it can be installed on the node. Beats also can be installed on the node, or Splunk forwarder also can be installed in container to get any specific containers log. This is how it works basically, that I implemented in my organization, in my company. Yes, Surya.
Yeah, will Splunk capture the container health and container application as well, or it will contain only the one?
So container health is uh, containers, to check containers health, to capture container health related data, we will be having Prometheus and Grafana, and application logs only can be stored or captured by Splunk or ELK stack. It is just
Yes,
for one.
exactly.
Yeah.
In that case, can we cover the Prometheus and Grafana for just only for the basic overview how this content health check is going to be captured, just for
I'll
our
try my
knowledge?
yeah. Once course content is completed, I'll try to get those things to tell you here.
Yeah, okay, perfect.
Yeah, because already our course content is having a lot of things. If you will be just going through them, a lot of things should be
Yeah, yeah.
covered.
The
Like
thing is that yeah, that's true. But apart from that, we are the some of the people are expecting for monitoring tools also as well.
okay, I'll try to try my best. I'll be telling you end of the course about ELK, basically ELK and Prometheus Grafana. I'll implement those things.
Yeah, fine. Are you using any cloud also as well in this session
Yeah, I will be telling few practicals, few examples on AWS cloud.
on the AWS? Okay, fine.
Yeah, because sometimes few things should be implemented only on cloud. So those things will be done on cloud only. Dynamic volume provisioning. How can I provision or dynamic volume in my personal laptop? And I'll be guiding you to create complete Kubernetes lab on your system, like on-prem system. How on-prem is having. We will be setting up our lab like this: one master and two worker node here, so that we can see each and every practical that how is done on real time.
Okay, parallelly on the AWS end also.
Yeah, AWS also. But that's what I said. If it is required, few things to be implemented on cloud, we will be implementing them on cloud. If it is not required, then we will be doing it on VirtualBox.
Okay.
One question.
Yeah.
Will you show how to implement this in Azure?
No. Azure thing is not be completed. I'll not be talking about Azure. Azure is like totally different, right? But don't bother if your Kubernetes cluster is created. If your Kubernetes cluster is created in AWS or Azure or GCP or Alibaba or IBM or Oracle, this will be same. Things will be same. Nothing will be changed. Only your infrastructure, to create your infrastructure method will be changed. Only one thing. But rest of the thing will be same.
Okay.
Yeah, guys. So, okay, guys, I hope you are okay with this, and we will be continuing from Monday. Nobody wants to say anything, guys? So okay, guys. Let's
This
join from
course
Monday.
is for how many days, Anish?
40 days, 1 hour per day. We will be
40.
doing it. Yeah,
Okay, from Monday to Saturday or Monday to Friday?
Monday to Saturday. If you need Monday to Friday, then also we can do that. But from the starting, we will be doing Monday to Saturday only.
Okay, please let us know that either this is a 5 days or 6 days in a week so we can plan it accordingly.
Definitely. We will be doing Monday to Saturday. That will be good actually.
Okay, fine.
Yeah,
So
actually,
okay, guys.
Anish, I mean,
Yeah.
sorry to interrupt. Yeah, in our organization we are using Azure, but I see in Azure we have a Kubernetes task and all. So if this helps to how to implement Kubernetes in my Azure also, it will help. Yeah.
So as if now, guys, actually the thing is that 9:30 I'm having my office meeting, so that's the
Okay.
reason. I will be talking this thing about on Monday. Okay, if you
Okay.
complete question you can ask me on Monday. I'll reply on Monday about it.
Okay. Thank you.
So okay, guys, let's connect from Monday.
Yeah.
Bye.
Okay, fine.
Bye, guys.
Thank you.
Thanks.
Bye.
Thanks.
Bye. Bye. Bye.